Alright, so on this, if I'm trying to get the sides being the same at the end, I need triangles being the same before that. Since I don't have any triangles, I'm going to make triangles. So we're just going to draw diagonal BD, and I'm just going to put the rule as just a diagonal. That's the same as we're drawing the auxiliary line deal. No big deal. Alright, if I see this right here, what am I automatically thinking about parallel? I'm thinking alternate interior, alternate exterior, all that junk. Which ones would be equal doing the alternate interior, alternate exterior stuff? I need some angles. Angles have 3 letters.
ADC,
All right.
ABC.
ADC? No.
ADB.
I can do ADB
That's what I meant.
And CDB.
and CBD. Those would be equal. So ADB would equal CBD. And what else can I do?
Another way around.
Other way around, I can do those there. So that I can say ABD is equal to CDB, and both of those are alternate interior. Well, what is something obvious that we should always do? The middle. So I'm going to say BD equals BD because of reflexive. Well, now what?
Whatever it is.
I can do the triangles now. So I'm going to say, if I said triangle ABD, what would match triangle ABD? CDB. Follow the angles, make sure we go in the same order. So that would be angle side angle. And if I have the triangles congruent, well, now I can say that the sides are congruent by CPCTC. This should be, if I can do it, an and right there. All right, same deal here. I've got to get to where I can say the angles are congruent. I can't do that unless I have the triangles. So since I'm trying to do the A and C, I'm going to draw in the BD. So draw diagonal BD. Just put in a diagonal. All right, I'm going to do the same thing. Get my alternate interiors. So I would say ABD is equal to CDB and ADB, CBD, alternate interior. I'm going to say BD is equal to BD because it's reflexive. I'm going to say triangle ABD is equal to triangle CDB, angle side angle. Once I have the triangles congruent, then I can say angle A is equal to angle C by the CPCTC. Now, I've got this other part,
I don't understand at all.
B and D. Alright. If I wanted to do the B and D, I would have to do that diagonal and work it that way, because I can't split up the angle that I'm trying to talk about. So both of them are the same proof. It's just you draw the diagonal BD if you're trying to do A and C. You draw AC if you're trying to say B equals B.
I don't understand this at all.
I don't understand any of the proofs we've done.
What I want to prove is that those pieces are equal and those pieces are equal. All right. Which means I need this triangle to be equal to that triangle. So if I've got that, then I can say the pieces are equal, right?
AEB and E.
All right. So I want to get those triangles to be equal to each other.
So
If it says parallel, I'm thinking alternate interior. So in those two triangles I just had highlighted, let me go back to that. I'm going to say that that one has to be equal to what?
Bottom C. Bottom C. Right there, C. Right there, yes.
So I'm going to say angle BAE is equal to angle DCE And what else can I say?
The B.
Oh, yeah. B.
I can say that one is equal to that one. So angle ABE equal to CDE because of alternate interior. That's almost a given on a parallelogram. You're going to talk about some alternate interior. Well, now what did we just say about the sides on that proof? The opposite sides are equal. Well, guess what? I'm going to use
AB.
that. So opposite sides are equal on a parallelogram. What crap? What is that now? That's angle side angle. So triangle ABE has to be equal to triangle CDE by angle side angle. And if that's the case, well, then DE equals BE and CE equals AE because of the CPCTC. Now, there is another way we could do this without angle side angle. Does anybody see it? What else could I have done besides angle
There's
side
a
angle?
vertical.
I could have done vertical and done angle side and it would have been the same thing. Nothing would have been wrong with that. So there's different ways of getting to it, but you've got to do the same basic steps. Get triangles being congruent some way, and then the CPCTC after that.
So if it was,
For this one, we're trying to prove what in this case?
BD equals AC.
So in general, what are we trying to prove?
Angle, the angle, sides.
Diagonals.
The diagonals are the
Diagonals.
same. We want to prove that the diagonals of a rectangle are the same. All right. It might be easier to look at it this way.
That's the
If I can get those two triangles to be the same, then I can say the sides are the same.
There's a right angle.
CD.
All right. What do I know about rectangles?
AB.
Right angles. So I can say that this is a right angle and that is a right angle. Well, I'm gonna say that. Angle BAD and angle CDA are right angles because it's a rectangle. All right, what else can I say?
AB and CD.
I know that AB and CD are equal
Sides
because they are opposite sides. They've got to be equal. What else can I say?
AD is equal. AD is
AD
That reflects it.
is equal to AD because it's the same side. Reflects it.
Then it'll be side angle side.
So then I can say triangle BAD is equal to triangle CDA because of side angle side, which means BD has to equal AC because of CPCTC.